Assalamualaikum warahmatullahi wabarakatuh. Salam
Waalaikumsalam
sejahtera untuk
warahmatullahi
kita
wabarakatuh.
semua. Terima kasih untuk sahabat yang sudah hadir di webinar kami kali ini dan tema NETPROMine Application on Nickel Project. Mungkin sebelumnya kita akan eh, melihat sedikit. Mungkin ada yang mungkin baru bergabung sebelum kita masuk ke itunya teknisnya. Jadi NetCad ini adalah perusahaan yang berdiri tahun 1949 sebagai leader digitalisasi data spesial. Berikutnya, MIRS merupakan perusahaan yang sedang berkembang dan untuk kita fokus di konsultan dan trading dan lebih ke fokus energi dan water. Kantor pusat kami berada di Office 8 Jakarta Selatan dengan operasional di daerah Cikeas. Kami merupakan eh, official partner untuk Share Region. Ini head office di Turki dan ini head office kami yang ada di Jakarta. Dan untuk tim-timnya, untuk dari NetCad, ada iGrim, ada Takbak sebagai technical support. Halo Takbak, we can say hello to participate.
Hi everyone.
And then Khatijah, dan di NetCat Indonesia diwakilkan oleh Bapak Yanes Darmawan, kebetulan sedang berhalangan, tidak bisa hadir di webinar kita kali ini. Dan selanjutnya dari Indonesia sendiri ada saya dan beberapa tim support yang lain. Dan untuk NETPROMine klien itu ada Sam Gobay, IPM, dan sebagainya. Untuk base klien itu ada Antam, ada Inung, dan terakhir ada Kideko untuk pembelian software Nepro Hydro. Dan untuk kampus, kita ada Unri, UHO, dan ITB baru masuk di tahun ini, dan Tekmira juga sama untuk pemerintahan. Nah, mungkin tanpa panjang lebar, kita langsung ke pembahasan aja ya. Oke, Takbak, you can start now for the NETPROMine application on nickel project.
Okay,
Okay.
so I will share my screen. Okay, I think you can see it now. All right. So actually, I also would like to talk about a new interface. This is a new version of NetPROMine. In this version, we bring the ribbon menu in another solutions that we have. We already had that structure, but NetPROMine didn't. So we bring that structure actually, and it's quite helpful. Also, you can always customize the ribbon menu. For example, this architect, I can send it here, so it disappears, or maybe for the quick access toolbar. Any kind of operation that you want, you can add that to quick access toolbar and you can use it. So besides from that, there are not much changes in the features that we already have. So if you know the previous versions of NetPROMine, it's not that different. So quite similar tools, quite similar places. We didn't change that much. To start a new project, as always, we are using the NetPROMine logo here. We are selecting new, empty project templates we are going to use, and I'm selecting a folder that I will save my project file. So it's a nickel project. I will use a nickel name as a project name as well. Okay. Once the project file created, you will also see that layers related to mine operations are also located under the nickel project now. So we are going to follow all the layers step by step, usually the borehole data, the cross sections, solid model, implicit or explicit model. We are saying it's solid model for that. And after producing a solid model, we are going to create a block model. We will make a composite operation for the borehole raw sample data. And then we are going to estimate the nickel grade value to the blocks. And then we are going to move forward with either open pit mining or underground mining. We are going to see the processes. I will try to explain as much as possible. And in here, after creating a new project file, we do have borehole input interface. So in here, we should read the color information first. So this is actually a borehole information. I also show you the file, the number or name of the borehole, the depth value, and Y, X, Z values. So the borehole name changes how much depth we have in each borehole and what's the starting coordinates. This information is needed for the first phase for the color input. So I'm selecting the CSV file. In the right-hand side, software asks what kind of information that it requires, and the left-hand side, we do have information that comes from the Excel file. So as we can see, actually, the columns are matching completely, but just in case it didn't match correctly, you can use that list and select the information once again. So, okay, we are going to click apply. It says process completed successfully, and it also gave us a note. So in the notepad, it says that some of the boreholes have same coordinates, which is quite correct because we have a lot of different boreholes that starting from the same location and going to different locations because of the angle information. There are some boreholes that starting from the same coordinates, but because of the azimuth and angle goes into another directions, which we will see. At first, we just read the color information. So there are some boreholes located here and here. I will just zoom the boreholes and rotate a little bit so we can see the boreholes. But all of them now are straight. So the second phase is going to be angle information. So that's why I click the survey. We are going to read the angle information for the boreholes. So in that file, again, we repeat the borehole name or number. We repeat the depth. But actually, it can separate it. For example, we have 25.5 meter depth for this borehole. But it can also be like till 20 meter, we might have minus 30 dip and 50 azimuth. But after 20, we might have different dip and azimuth values. In that cases, we just repeat the borehole number and we separate the information. So 20 to minus 30, 25 to let's say 40, we do have another dip or azimuth value. So it is also possible that you can read the boreholes that has different directions in the different levels. So the information we are getting from this file is that depth, dip, and azimuth information. Why we are repeating the borehole number? Because of our structure, basically. Okay, after reading this, I'm going to show you. So the depth information has to match with depth, deep, and azimuth. Okay, now I can apply. Okay, because process is completed successfully, we got checks also in that sections. And I would like to show you the main part. So this is the main part that we have. We do have some boreholes starting from the topography, but we do also have underground boreholes. And also we do have some boreholes in another location, a little bit far from here. And later on, I will also show how we can manage those boreholes. Next, we are going to read the geology information, but I also said that I'm going to show you why we repeat the borehole information, because in the first file, we are creating the borehole information section. So in that part, we do have the borehole name, depth, and the coordinates information that we provide. We are just filling all of the sections. In the second phase, we do have the angle records, so depth, deep, and azimuth values. So at the moment, we don't have lithology, which I'm about to import that file as well. And then we are going to read the raw sample records, which is analyze values. That's why we are filling the information cards. We can say information cards, borehole, or borehole ID cards. Okay, so click geology. I'm selecting the lithology file. In that one, we do have a couple different lithologies in different levels. For example, for 72, borehole number 72, we do have S lithology in between 0 to 24, in between 24 to 24.2, we do have K lithology, and goes on. So, okay, this is the format of the lithology file from to starting point, ending point as a depth, and then lithology information is matching correctly. So I will just apply. Okay, so we do also add the geology information, but it's not possible to see directly on the screen. Later on, we are going to give different colors to the different lithologies. The next step is raw sample information. We have some raw sample data for some of the boreholes. We would like to add that information, but once you click the raw sample information, you will get that notification. It says enter project attribute information. So basically, the software can be used for a lot of different types of projects. It can be a coal project, nickel project, gold project. Therefore, you need to define which attributes that you are going to work with. So in this case, we are going to work with nickel information, and I do also have cobalt attribute too. So for the nickel, I'm using the ppm, and for cobalt, I'm using ppm, because this is the analyzed values that I have at the moment, and I would like to import that analyzed values to the boreholes. That's why I defined two attributes that I'm going to work with, and click OK. So now I can read a raw sample information. Once I click that, it will open the window. Let me show you what's inside also. So borehole number, we don't have that here. For example, in this borehole, 7 to 166. So in that borehole, for example, in between 0 to 3 meter, we do have 83.27 ppm cobalt and 2100 almost ppm nickel. So in different levels, we do have different analyze values. It's a little bit similar to lithology file. For different levels, we do have different attributes. Okay, now we are going to import that file. Okay, there are some mismatches in this one. Great, I'm not going to use cobalt and nickel. Okay, so another process is complete. We also add the analyzed values into the boreholes. So that for information is quite enough for us to move forward, because we are going to produce the composite data anyways. And if we have a seam information, which we don't have in that project, but if you're working with a projects like coal, for example, you would like to add the seam information to understand the correlation between seams. So mostly you are going to work on the seam information, but in that case, we don't have the seam information. Surface, we can import surface anytime that we want, and it's also similar for the fault lines. So that for information is good enough for starting a project. That's why I'm closing this window. Now we can check what we have in our hand. So we do have some boreholes in place A and place B. We do have separate information as well. But first thing I would like to do, I would like to check the properties of the project again. If you remember, we input the attributes here, and near to that, we do have lithology colors. I can give all of the lithologies, but just I would like to make red color to lithology K because we come across nickel in that lithology. It's a real project file actually, but we don't have the quite good information for all of the data. It's just a simplified version of a project file, let's say that. So I just made a different color to K. If we want, we can give some different colors to another lithologies as well. But just remember the K, this is the main focus of ours because we come across nickel in that lithology. So let's just colorize other lithologies as well. Maybe orange. Okay. If we want, we can also assign some patterns like sand, claystone, sandstone to the lithologies. You can always assign some patterns. to lithologies. And I will click OK. So as you can see, now all of the lithologies are represented with related color that I established a second ago. So now we can see the boreholes and we can see the lithology information. So mainly we do have lithology information in here. Maybe we don't have detailed lithology information in here. And let's check. Yeah, we do have lithology information in here as well. So now I can see different lithologies in a different color on the screen, but how do I manage that boreholes, you might ask? So what I'm suggesting in that kind of cases, just check the boreholes. For example, it's in a different zone. I would like to filter that boreholes, create a new group as a maybe zone, second zone. Okay. So it's the second zone group. So I do have another borehole group now. And what else we have here? We have boreholes that starting from the topography directly, and we do have boreholes underground. So for them, I can also make a separation. Therefore, we need to use a filter. So actually, I don't need to select any of this information right now because what I would like to do is just area filter. Therefore, I'm clicking here, draw an area. If I don't have any area that I can select, I need to draw from the beginning. I will just check the boreholes. Okay, so I would like to filter boreholes that is inside this drawn area. So when I click OK, you will not going to see other boreholes on the screen, just the borehole that inside the area. And if I click the plus icon here, you will see that there are a couple of boreholes are in the list. We do actually have 244 different boreholes, but now we do have only 18 of them. So this is the filtered boreholes. What I can do, I already make a selection. You can also make a selection like that too. Right click on those boreholes and send them into a second zone group. So, okay. Now, if I remove the filter, we will see that now I do have two groups, and if I want, I can uncheck and I can deal with only these boreholes. Let's make another filter to separate these boreholes from underground boreholes. I will use another group, let's say survey drillings. Okay, this is a third group, starting from the survey, the topography. So I will use a filter this time. And the obvious way that I can filter those boreholes is actually the elevation. because it starts from here. So if I use elevation limits, for example, here, I might filter the boreholes above that elevation or sorry, above that elevation or under that elevation. So let's make it for the Z elevation value, I'm going to say higher than some value. How can I know that? I previously used the -X view, and if you use that view, the elevation will change dynamically and it's a true elevation. So if I say 1300, for example, higher than 1300, and use filter, I will have boreholes that starts from the survey. So these are the boreholes that starts from the topography. I made a selection, select the third group. And again, I'm removing the filter. So now I do have information. So some boreholes over here, I just uncheck the second zone. I do have different types of boreholes here, so I uncheck the other one. And now I only have the boreholes that are underground drillings. In that case, we might work with either lithology or a raw sample. In the raw sample, I mean the nickel or cobalt or any kind of attribute value. We can use those attributes and we can make a grade model, or we can use lithology to create a model. So in that case, what kind of data that we have, I would like to show you. If I make a raw sample display.
Drill hole ini, Prik? Hah? Emas sini. Emas sini.
Okay. If I make nickel attribute display, so we will see that we do only have information in here. So we don't have all of the grade information of the nickel. But I know that we do have nickel in the selected lithologies. All of the lithologies that we have as a K, the red ones, we do have the nickel. So in here, I know that the highest ppm nickel is located. But I also would like to see the lithology. So the K selected, and I'm selecting the show lithologies future here. When I click OK, it will just, oh, sorry. I didn't filter all of the boreholes, so okay, now oh, because we do have the Z criteria. Okay, now it will work. All right, for all of the boreholes, we filter the K lithology that we come across with the nickel information. So this are the depths that we come across with the nickel. It is a quite good example that we can produce a solid model from it. In the metallic minerals, especially the metallic mines, implicit model works so nice. So we can either draw a cross section, or we can use implicit model directly, and we can create a solid model. So we can create the first solid model. If you're going to use the cross section option, it will take a lot of time of yours, and you might make a mistakes in that kind of projects, because there are lots of lithologies are separated. We would like to model it, but drawing a cross section is quite hard for that kind of minerals. Therefore, we are going to use the implicit modeling, geological modeling features. So the first one is lithology, and the second one is grade. As I told you, we can make two different models, but the logic behind it is quite the same. Therefore, if you trust one of the informations, you can create your solid model from that option. So I trust lithology more than a grade information, because I know that we don't have all of the grade information of the minerals. Therefore, I'm going to use lithological modeling, and from that K lithology, the lithology that we come across the nickel, I will use, and I will create a solid model. So let's do it. I use the lithology. So it gives me a grid quite a bit. Now I would like to limit that grid. We didn't select the... So I'm not going to use the second zone. Survey drillings and ungroups are okay as a borehole group. As a lithology, we are going to use the K, right? Okay. Once we didn't select the second zone, our grid is already got smaller. So yeah, now it's fine. Actually, we are just aiming to get boreholes that we are going to create a model from it inside the grid. So all of the material should be inside the grid. If we want, we can limit the grid as well. Let's draw an area. Now I'm drawing area. It's going to be a boundary, so that we are going to use that boundary to generate some RBF points. I'm going to explain what is the distance function point, or RBF points, in a minute. So this is the area that I would like to use. If you would like to limit the grid for your project, you can also draw a boundary and click here, select the grid boundary, right click, introduce that to software. So from the beginning, we select the K lithology there are some other options like minimum ore thickness and minimum waste thickness. So what are those options, if you wonder? So in a minimum ore thickness, if you have some criteria, let's say if it's less than 10 centimeter, let's say, it's not going to produce some points around that lithology. We can eliminate some of the thin lithologies. For example, this one is quite small. If you want, we can eliminate that kind of lithologies. With that, actually, we are not going to take those lithologies into our main ore body, but usually they are quite close to each other as a group, so we don't have too much separate lithologies here. If I wanted to remove them, I might remove some of the lithologies inside too. That's why I don't want to remove any thickness here. Also, the waste thickness stands for the distance between lithologies. So you can also say that to a software, okay, I do have two lithology, but the distance between them, if is, let's say, less than 20 centimeters or something, it will combine, it will consider those lithologies as a whole big lithology if there's a distance lower than 20 centimeters, for example. This is an option for that. And with beta and C values, actually, you can adjust the distribution of the resulting points and the distance points. This is uncertainty criteria. Actually, let me explain by using good old friend. So why do we want to adjust our resulting points? Because we do have boreholes, and in that implicit modeling, we are actually producing some points around the lithologies that we consider. In our project, it's going to be a K lithology. So if we have a really big distance between boreholes, let's say 200 meters, then if we don't use uncertainty level or the beta value to adjust our projects to actually adjust our implicit modeling entries to our project, it's going to produce some points, but it will consider them as separate points. So it will say that you do have some material over here, you do have some material over here. But in a projects like coal, for example, it's all connected actually. So we need to consider them together. So you can adjust the B, beta, and the C values. When you adjust those values, it will just create larger points around the lithology. So they will connect. And we are going to have a seam model like that. But in this project, if you check the beta, it's just 17 meter distance in between every borehole average. So we don't even need to adjust. It will probably create a quite accurate points anyways. It's so close. Yeah, those are the criteria actually. If you have a larger distance, you can increase the beta and the C value, so you can adjust. It might require some tries, so you will try them. You will run the software and you will see the distribution of the points. Which one is suitable for your projects? You can use that distribution. Regarding the grid points, so now we do have that grid, basically, and we also create a boundary. What it does is actually this grid is not a empty shape. It's also a boundary, and by defining X, Y, and Z sizes, we are actually creating a point. It's that grid turning into a point cloud. In that image, maybe it's a little bit small for you, but you can also see that we are creating points every 4 meter in the X and Y directions and 2 meter for the Z direction. So we are creating the corner point. Let's say 4 meter later, we have another point, but 2 meter lower, we have another point. So that grid shape turns into a point cloud. And then we are calculating the distance function points. So wherever we have that K lithology, it will turn into minus points, and the rest of the levels, let's remove the filter of the boreholes for a second. So when that points are intersect with the boreholes, it will give you an idea in which points we do have minus value. So it will say that you do have lithology. Let's just create the distance function points. So we will understand that actually it is going to create a quite similar copy of our lithology and the borehole data. Okay, so now I will uncheck all of the layers and I will just open the distance points. So distance point plus represents the rest of the points that doesn't intersect with K lithology. Also, at the same time, the minus points, I will just uncheck the boreholes now. So those minus points actually representing the levels that we do have the K lithology. So it's just a quite similar looking. It has a quite similar looking to boreholes when I filter the K lithology. So this is actually what we want. So the software defined the minus values, and by using the grid, it is going to make a calculation now, and it will provide us the potential points that could be minus and could be positive. So we need the minus points. So software will give us the potential minus points inside that grid. For that, we are running the RBF function. I'm clicking the produce model part. So RBF means radial basis function. On the backhand side, one radial basis function works. So it calculates and make a estimation for us. All right. So we generate some points around the lithologies. Let's remove the grid. Let's remove the distance minus points. So this is the potential points that we might have as a minus. Let's open the borehole information again. So it quite fits, but in some parts there are some information that is maybe because of the boundary limit. It also tries to generate some points, but it is totally fine. What we are going to do now is we are going to produce a model, a mesh model. At first, I'm not going to touch any of the criteria. I will just say click apply. Okay, this is the first model that software produced without doing anything, right? So it's just trying to cover all of the RBF points. So what we can do, we can just increase the model detail, and we can generate another. I will also give transparency to the new model that is going to be produced, and orange color I will select for the new model. I increase the model detail only and give some transparency and give a different color. So now the second model that we are going to produce will be much more closer to the RBF points, as you can see. So the green one is also a solid model, and the orange one is also a solid model. In that part, users should make some evaluation and check the results, how the model is produced, how it's look like, and then decide according to his or her experience. Then it can they can move forward in the later procedures. But what I see in that part, there are some extras. For example, we do have one lithology here, yes, but we do have lots of points for that lithology also in this part. So what can I do in that kind of cases? What if I would like to remove some parts that I generated, but I don't want to involve into main or body? So for that cases, you can simply select an area and remove that part. And the next one that you are going to produce, that part will disappear. Let's do it. Right click, draw an area. So this one is going to be area 2, a different layer we are creating. So I will draw an area, and I will select this area now so that the software can get that information. Okay, I made the selection. So the next model that I'm going to be produced is going to be another color. I am not changing other criteria, so I will click apply. There is actually one small trick in this. If it doesn't produce a model different, if it's also producing the same model, you just need to change the direction, because according to the area that we draw, that part could be under the area or above the area. It depends in where we draw the area. So if it doesn't remove the part that you would like to remove, you just need to change the direction. So we don't need that because we already removed that part. And seems like our geological model is quite good. So you can see every K lithology and this solid around it. There should be also our, yeah, in here, if you can see, in zone 2, we do have our boreholes, but we didn't produce any points or we didn't use any information from them. We just worked on this part because at first, when I was creating the distance function points, I already make a borehole group selection. Therefore, we didn't include the second zone boreholes into our geological model design. So, yeah. Also, from the section borehole analysis, you can bring the borehole axis. Once you click it, there will be other layer, and under the other layer, you will see the borehole axis. If you click it, you can also see the starting and ending point of the boreholes as an axis. And another thing, if you would like to show the triangles on a geological model, you can just right click and select the style option. And the style option, we do have area borders. If you select that, you'll also be able to see the triangulations that we made while we are creating this geological model. So, yeah, this is what we have. But in NETPROMine, we are not assigning attributes to geological models. It has some attributes, kind of like volume, some coordinates, center, location, etc. But the information that we actually want is the analyzed values. We do have a geological model, but we don't have how the analyzed values are distributed. So I do have a material in that location, in here, that is quite okay, but what is the ppm distribution in the geological model, right? Therefore, we need to create a block model. To create a block model, you can just right click on a solid model and select blocking. So 4 meter in every direction. It's actually become a cubic. You can select the block sizes as much as you desire. And according to that decision, it will just create a block model that represents the geological model. Okay, so this is our block model that actually represents the geological model. Or if you would like to go into detail too much, you can also use subblock criteria. and you can halve the main block sizes, and you are going to create smaller blocks near to the edge, and inside it's going to be main blocks. So let's say we do have a geological model like that, right? Inside we are producing a main blocks, and near to the edge it creates a smaller blocks. To represent the geological model even better. With that, you're not missing even small portion of the volume, but you should also be careful again. What is the volume of your block model? What's the volume of a geological model? So let's also create another block model by using the sub-block criteria. Okay. So you can also see that there are some smaller blocks. Let's see if we can, yeah, here, look. Inside, we do have a main 4-meter size block, and near to the edge, near to the surface, we do have smaller sub-blocks. So with that, actually, we aim to increase the representation percentage. What is it? Let's check the block 1, check the properties. So it represents 86% for geological model as a volume. And let's check the other one. So it's 93.5 representation as a volume. You can change the block sizes. You can adjust your block model into a geological model. So as a volume, you can also get better representation rates. You can change the size. You can increase maybe the sub-block criteria. Let's turn back to that scene. If you increase sub-block criteria as a 2, for example, it will create even smaller blocks. So 1 meter in every size. So it will also increase the detail. Okay. So once we have the block model, what should be the next step? The next step should be the assigning values. We do have some nickel and cobalt values in our software, even because we import the raw sample data, we import the analyzed values into the boreholes, but we are not seeing it. So this is our model, and every block is going to carry one analyzed value. For that, we are using estimations. We are using some estimation methods. Before that, I will just create a composite. So the name is going to be C1. There are some length and percentage information. So if you would like to decide more statistical way, you can also check the length statistics of an attribute, for example, nickel. So nickel actually exists minimum in a 50 centimeter, so half meter, in average 1.26, and maximum it says 3.5 meter. So you can decide what should be your minimum composite length. In that part, what we do is actually, let's say we do have lithology here, right? Okay, lithology. And we do have some analyzed values like 2000 ppm or 1900. So we are actually making a distribution. We are separating that information into 1 meter levels. Even if it's, let's say, it's a big information, maybe we use 2000 ppm for whole 10 meter lithological. So it separates the information anyways into 1 meter pieces. If I click 1 meter here, of course. It separates the information, even though it has the 2000 ppm. It separates the information because later on, when we have a block, we would like to assign that value into by using composite value in the right location. So that levels might carry different attribute values. So while we are assigning, we should consider that composite levels. At the same time, when we do that process, we are also creating sample information. I will select the attributes. I am not selecting a borehole group. I think it's okay to create a borehole groups. The other one is not going to affect too much anyways. It's quite far. And yeah, and I'm clicking OK. So now that I do have a composite, I can make a distribution. In a distribution or estimation methods, there are some different type of methods. For example, if we get information from the nearest boreholes directly to assign a value, so let's say it's a 3000 and this one is a 2000, so it takes roughly 2500, 2500 and make the assignment. So basically it make a distribution for the nearest borehole. It doesn't have too much detail. So let's make one. For that, all you have to do is just select the attribute value and it will assign some values into the blocks. In the other hand, we do have another method, which is called inverse distance. Let's use the other block for that purpose. So from the estimation methods, I'm selecting the inverse distance. In this part, actually, we are using an ellipsoid. If you check ellipsoid here, you will be able to access show ellipsoid future as well. And when you check that, you are going to have the ellipsoid parameters. So from that, you can choose the center location of your block model. Basically, the main center point is not that important because when we use the inverse distance method, there are some blocks, let's say, right? Just maybe extending that process into a longer time, but just for the better understanding. So let's say we do have a borehole here, right? So when we create an ellipsoid, we are actually getting information from the ellipsoid. So whatever is inside the ellipsoid, we are getting general information, and then we are assigning for a block. But that ellipsoid is actually visiting every block center location and gathering information, then assigning to each block. So for this block, for example, the ellipsoid will be like that, let's say, and it's gathering information from the boreholes or the blocks that already have the assigned value. So it's iterating and it's finding the potential value that block can get. But while we are making this distribution, the ore direction is quite important as well. If we do have ore body that has a certain angle, so let's say our ore body moving forward with some degree, then we can create an ellipsoid that follows the pattern, because in this way actually we will be able to assign the right value, because it's the ore body's pattern. If it follows some sort of angle, let's say 30-degree, or I don't know, 150, right? So if it has some sort of a angle, we can also adjust our ellipsoid for estimation purposes. So we talk about the ellipsoid. As a layer name, I'm typing ellipsoid. I will create an ellipsoid in the color that I choose. And I already choose the center location of this block model. Again, I'm telling, doesn't matter making a main center selection, because ellipsoid visits every block center location. And then let's apply first. Okay, this is my ellipsoid. I need to adjust that ellipsoid into the so it just has to follow the pattern that my ore body has. Okay, both of the samples are actually looking quite similar. It seems like it has a small degree in that side, right? I adjust my ellipsoid. Let me show you from the minus Z direction. You can adjust the azimuth, for example. So the direction is actually that way. And then you can use the minus X side, and you can check its deep or rake. and then you can adjust. Actually, there are two separate blocks. We could have done that operation by separating the blocks as well. The first block, I can do my estimation, and the second block, I can do the estimation. It is a little bit detailed, so that's why I didn't do it, but it is also possible you can make an estimation for the block 1 and for the block 2 separately. So let's say we accepted the ellipsoid parameters, the angle information, the rake information, the azimuth information. Then we use the synchronized settings. So all the ellipsoid settings are going to be located here as a ellipsoid sizes. So 40 meter in length, 25 meter width, etc. So also we are getting the azimuth, dip, and rake information directly. Once we click OK, by considering this ellipsoid direction, it also does the distribution. So yeah, we made the distribution. I will just uncheck the ellipsoid from 3D layers. So this is the block model after estimation operation. Also, I would like to mention that when you do any kind of estimation, the software directly splits the minimum and maximum information into 4 pieces, but you can make different or you can create different thematic ranges. For that, under the block, I'm right-clicking the thematic operation, click Edit, and selecting a new numeric range. For NECAL. So minimum is 0, maximum is 2.25. So I can split that information into, let's say, 300. Every 300, I'm going to create a one range, one interval. And I will select rainbow colors. Okay. It didn't change too much, but we split that information. So the mainly, we do have blocks that has less than 300 ppm over here, and the core center, actually, we do have more valuable blocks. And if we get a report, let's get a block report. Let's say 2.7 density. So it's going to show me in which range I do have a material. For example, in between 300 to 1500, I don't have information. But in that ranges, it also shows me how much volume I have and how much tonnage I have. And it gives the average ppm. Okay. So once we do our distribution, the next step is understanding the potential of the mineral. So roughly we can get a block report, and we can check the potential volume and the tonnages. But how we are going to turn that into a project? Is it either going to be an open pit project, or is it going to be an underground project? For that, we can use actually optimization to understand what is the cutoff grade. If we, for example, let's say if we use option number 1, open pit design, how much excavation we are going to make? Is it going to be profitable to create a open pit, or does it have to be an underground design? So in those options, actually, we can use the optimization. So just for that, I need to add the surface file. So this is the surface file over here. And this is the original topography that we have. And when you import a different data into a NETPROMine, first it will take that information into a 3D layer. Then you can get that information into our layers. For example, create a surface section. I will add this surface to my project file. Okay, so now I can remove that demo surface in data. And I have that surface under the surface layer. So it's in my project now. I can rename it as a topography. I can change the style. Let's make it a dusty look. Yeah. At the same time, it's looking quite close to a surface in some parts, but it's also in the deep. So it's maybe hard to decide. So let's move forward to the optimization part. For that, I will use another tool. Just a second. Okay. I shared my screen. So this is NetMine plan. If you knew the NetProMine from our previous webinars, the optimization package was actually inside the NetProMine, but we actually create a new software for it. After that, we are going to add lots of features into that, but now with the new version, we are also running optimization in NetMine plan software at the moment, but it directly works with your project file anyways. So I created the block 1, right? So now I do have the blocks and also the topography. For the optimization, actually, this is what we need. Let's get to the optimization part. First, we need to select the block model, define it for the software. We are defining the slope angles that we are going to use. Okay, I just select 45 degree. Then we are deciding the optimization settings. I will do strategic planning because I don't just want to see the ultimate pit limit. In the options, I will use the floating column. Okay, strategic planning. So for the ore, actually, I need to add a mineral type. Nickel here. As attributes, I already have nickel information in the blocks. As a period, this is annual capacity. So annually rock tonnage that you can extract in a year. Moving forward with the cost information. So I will add one process here. And inside that process, mining costs, mineral processing costs, sales costs, mineral density. I'm inputting that information, although it might be slightly different than the original values at the moment, but this is just an example. You should always check the exact prices for that operations. In the price section, okay, this is the tricky part because we use the ppm and I need to be able to find the price information for a nickel that I will use. So we are not finding a price for a tonnage of a nickel. We are using ppm information and the grade. So we need to stay close to that information. Later on, we are going to select a unit for nickel price input. Therefore, I'm just leaving it here for a while. So metallurgical cost per ton, prices we had, waste field, waste density. Waste mining cost will be the same with the ore mining. Process capacity, okay, let's say 500,000. And as a recovery rate, I will use 60%. And in the advanced options, this is the investment rate. Sorry, interest rate actually. Every year your costs might increase in some percentage. This is why we are defining that criteria to adjust economical changes, to adjust our project to economical changes, basically. I'm not typing that. Okay, while we go deeper, our expenses might also get increased. So that's why I define depth coefficient. I suggest not defining too high number into this one because for every meter, the cost is increasing. So let's say for this example, if I'm spending 100 in the first level and the second level, I'm spending $102. But if I define something like 10%, it's going to increase too much per meter. As a sales price, okay, I will use gram. It's quite close to the ppm at least. As a gram, I will try to find the price that we can make an operation, and we can't make an operation because we are going to find cutoff grade also. And according to that, it will say that, okay, if this is the value, then you can operate it or you can't operate it. Well, the software will show us the results, dilution amount, and the recovery amount. Stockpile, I would like to see in the report if some ore material will go to a stockpile. I would like to see it. And I would like to see the optimization limits as well. Okay, this is all the criteria except the price. So as a gram, I will just say $1 per gram, just for experiment. Okay, so click OK. Methods. Let's check the prices. Okay, something software didn't like, maybe because of those parameters, or maybe we just okay, nickel as a ore. Capital investments. Okay, let's try this method then. Actually, some parameters that we define might have a problem. Okay, let's try that again. We already have the parameters. We want 5 or costs 2, 1.3, 0.7, 3. Capacity 500,000. 60%, I'm going to say. For that, I will stick with floating cone. Let's see how it reacts. If it doesn't allow us, again, we can continue on the other one as well. Okay, it didn't like some of the parameters, but I didn't quite get it. Just give me a second. I'll be back with the previous one.
Oke, udah selesai. Takbak is finished.
Just the small parts.
Oh,
You
okay.
will also see that how to decide either it will turn into an open pit design or underground design. So I share that again, the nickel project. So I would like to make an optimization for the block 1. Okay. So let's just type the information once again. Sorry for that. So 45 degrees, okay. optimization settings, mineral attribute 5, 1 process, 1. Okay, prices. Okay. So I will just begin the optimization. I will select the surface. Actually, it's quite important to have original topography because otherwise our all calculations will not going to be accurate because the actual amount that we are going to excavate, we should know basically. So it finds some economical cutoff grade. I'm believing that the price is quite high anyways, because per gram it's $1. It's quite high for that. So I'm thinking that it will take a lot of material. Okay, so the resulting window, I will just create a pit surface to see what we are getting. So actually, as expected, it focused on the main core that we do have a high ppm nickel. So it suggests that we should excavate this area. And let's check the point model view. So the first year of excavation and the second year of excavation and the third year. According to 1.5 million mineral capacity that I defined, it actually divide that excavation area into 3 pieces. And it was a quick preview. Let's generate a block model. It is actually the same thing, but it will create a block model this time. And after that, we will be able to get a plan report and a details report. And in the plan report, we will see the economy for this. It's generating now. Okay, in the production, as we can see, the number is quite high, like 52 million. And okay, the price we defined $1 per gram of a nickel. It's a little bit high. That's why we do have a high NPV here. But we can actually see what's the tonnage of a material that we are extracting also. And we can see the valuable parts from the optimization. So this is actually the valuable. Let's change some of the parameters and run that again. So for the block 1, I will change the price and mining capacity information. Let's say 1 million per year. Maybe it's going to create 4 different periods. And as a price, I would like to say 0.1 this time. Okay, and begin the optimization. It may not have too much of a difference. Still, I'm thinking that it's a little bit expensive for a gram of a nickel. Therefore, it may find a quite similar area, but the report will be different, definitely. So let's create a pit surface. Yeah, it's actually quite the same. Let's give that an even smaller number as a price. 0, 1 this time. Okay. This time even maybe we're not going to get any kind of result. Yeah, it's probably not profitable anyways. Let's see if it can produce a surface or any kind of a result. I wonder. So yeah, there are no producible surface for that price. So it should be higher than that. But at the end, we are using that surface to create open pit later on. Let's just get surface boundary of it. Okay. And in the original topography, I'm capable of seeing that boundary, so I can use that boundary to make an open pit design. I'll just do it quickly to give you an idea also how easy to create open pit in NETPROMine. I know there are lots of topics to cover every time. So today we were just working on estimation and the project input for the NETCAD data. Therefore, I couldn't show all of the features, but just quickly, I will show how to make an open pit design in, let's say, seconds, just to give you an idea. So our design is going to be downwards and inside, so I can arrange the parameters as I wanted to. This is the general slope angle. We use 45 degrees, so it's quite close, 47. And I can add a ramp too. And the starting point could be this location. Okay. Let's create a couple of bench. Okay, so let's say I want to create the last one. I can change the of a ramp, say starting first. Okay, like that. So don't want to take your time too much to refresh the surface. To give you an idea how to create an open pit using this boundary basically. So we are going deeper into the ore body. So what we aim is eventually we would like to get that surface. So we're close into the final surface. If you're also going to get the lever and we will live, it's not going to worth excavating for those. But actually, in reality, this project is underground project. And I would like to show you again the similar part. Just okay, center line. This is and if you